Now is the time to prove some theorems, corollaries, propositions on graphs. So the first one, it says the total degree of a graph is even. To prove this statement, we will say since the sum of the degrees, because it says the total degrees, sum or total. So here you can say total because the question says total, or you can say sum. Since the sum of the degrees, and we will write the equation, I equal 1 up to n degree vi is equal twice number of edges, and remember number of edges is integer. Since the total of the degree is 2 multiplied by an integer, then it is even. Okay, and this is very simple to prove. Now for the next proposition, it says in any graph there are an even number of vertices of odd degree. So if you count all the vertices of odd degree, you have a graph, you just count them. How many of those vertices of odd degree? Their count is always even. So the number of odd degrees in any graph is always even. We will start the proof by first defining let G be a graph with V vertices and also let SE and SO be the sum of vertices of even and odd degrees. So V will be a set, but SE and SO will be numbers. So SE represents the summation of all vertices of even degree, and SO represents the summation of all vertices of odd degree. So then we will have the definition. We will say summation V belongs to capital letter V, which is V, will be equal to summation of all vertices of even plus summation of all vertices that are odd, and this is equal to twice number of edges. So from this equation, this is even and this is also is even. Why it is even? Because it is twice number of edges. Rearrange the equation. Then we will have the sum of all of odd degree is equal to twice number of edges minus SE. So we have even minus even. So the answer is even. So we know now the summation, which is this one, of all odd degrees is even, but that does not indicate that they are even. It says the summation is even. Summation of all odd degree is even. So we have to elaborate more. Now notice that, I'm going to write it here. Notice that all vertices summed in SO are of odd degrees. In other words, this summation has been obtained from the summation of only odd degrees. So they are summed of only odd degree. Hence, the sum of odd degree vertices is even only if the number of these vertices is even. Okay, let me elaborate more by an example. Now imagine that we have SO is the summation of odd degree. Let's say 1 plus 5 plus 7, let's say 9. Now you know that if you add odd and odd, you will get even. Okay, so that means every 2 gives you even. So if you add one more here, so 1, 2, 3, 4, 5, then this will be even, these will be even. So even plus even is even, but even plus odd is odd. So you will not get the summation even. So therefore, the number of odd vertices in the summation should be even, otherwise the summation will not be even.